Alright, so in my last video, I actually showed you how to calculate these 5 integrals. And this is what is called the orthogonality of the trigonometric functions. In this video, what I want to do is actually start talking about the Fourier series, specifically Fourier series of functions of period 2 pi. Okay, so every function with the period 2 pi can be represented by a trigonometric infinite series of the following form. Okay, so this is f of x is equal to a0 divided by 2 plus the summation from n equals 1 to infinity of a sub n cosine of nx plus b sub n sine of nx. Okay, so if you have a function which is a 2 pi periodic, okay, we can represent it in a series of this form. And in order to, however, write the series in this form, we need these coefficients, a0, an, and bn. Okay, so in this video, I'm going to show you how to actually calculate these coefficients with the help of these integrals. Okay, so let's go ahead and do that. So here is my Fourier series. Okay, so what I'm going to do here is I'm going to multiply both sides by the cosine of mx and integrate from negative pi to pi. Okay, so if you multiply the left-hand side here and integrate from negative pi to pi, what we get here is the integral from negative pi to pi of f of x cosine of mx dx. Okay, and that is going to equal to a0 divided by 2, okay, which is just a constant integral from negative pi to pi cosine of mx dx, okay, plus the summation from n equals to 1 to infinity of a sub n, okay, and then the integral from negative pi to pi, okay, of the cosine of nx times the cosine of mx dx, okay, plus the summation from n equals 1 to infinity of b sub n integral from negative pi to pi of the sine of nx cosine of mx dx. Okay, so that is what we get when we multiply both sides of this Fourier series by the cosine of mx. Okay, now what you would notice from the previous integrals that we calculated is that the cosine of mx integrated from negative pi to pi, that is 0, okay, and also the cosine of mx sine of nx dx integrated from negative pi to pi, that is also 0, okay, and that holds for whether m is not equal to n, m is equal to n, and m is equal to n equals to 0. Okay, so in this case, then this integral here will go to 0. Okay, and this integral here will also go to 0. Okay, this integral, however, okay, this is the cosine of nx times the cosine of mx dx. This integral is 0 for m does not equal to n. It's equal to pi for m is equal to n. Okay? But yeah, m is equal to n but does not equal to 0. And is equal to 2 pi for m is equal to n is equal to 0. All right? So this integral here, okay, all of these terms in the summation will go to 0 except for the term where n is equal to m. All right? So this integral here is just equal to pi for n equals to m. Okay, so what we get here is the integral from negative pi to pi of f of x cosine of mx dx. That is going to be equal to a sub m times pi. Okay, that's because all these terms in the summation will go to 0 except for the term where n is equal to m. All right, so from here we can calculate a sub m. Okay, and this is just equal to 1 over pi integral from negative pi to pi of f of x cosine of mx dx. Okay, now what we're looking for is a sub n. Okay, but here m is equal to n, so I can just write this as a sub m, a sub n. Okay, so this is going to be a sub n. This is equal to 1 over pi, the integral from negative pi to pi f of x cosine of, this time, nx dx. Okay, so that is my coefficient a sub n. Okay. From here, I can actually also calculate this coefficient a sub 0 because that is just when n is equal to 0. So a sub 0, well, that's just going to be equal to 1 over pi integral from negative pi to pi f of x cosine of nx, but n is 0, so in the cosine of 0 is 1. So this is just going to give us f of x dx. Okay, so this is the coefficient a sub 0. All right. Okay, so we have a sub 0 and we have a sub n. Now we need to calculate b sub n. Okay, and we're going to do the same thing. We're going to multiply both sides by, this time we're going to multiply by the sine of mx and integrate from negative pi to pi. Okay, in order to calculate b sub n, we're just going to multiply both sides by the sine of mx instead of the cosine, and you'll see that we will be able to calculate b sub n. Okay, so let's go ahead and do that. Okay, so if I take my Fourier series, which is f of x, that's equal to a0 divided by 2 plus the summation from n equals to 1 to infinity. Okay, so a sub n cosine of mx or nx plus b sub n sine of nx. Okay, so this time I will take my Fourier series, multiply both sides by the sine of mx, and integrate from negative pi to pi. So on the left hand side, what I will get is the integral from negative pi to pi f of x sine of mx dx. Okay, and that is equal to a0 divided by 2, the integral from negative pi to pi, okay, sine of mx dx, plus the summation from n equals 1 to infinity of eighths of n, integral from negative pi to pi, cosine of nx sine of mx dx, okay, plus the summation from n equals to 1 to infinity b sub n, integral from negative pi to pi sine of nx sine of mx dx. Okay, and once again you'll see that this integral will go to 0. Okay, and this integral will also go to 0. Okay, and that's because, remember, that the integral from negative pi to pi of the sine of mx dx, that's 0. And the integral from negative pi to pi of the cosine of mx sine of nx dx, that is also 0. And this integral, the integral from negative pi to pi sine of nx sine of mx dx, well, that is 0 for m does not equal to n. Okay, and it's pi for m equals to n. Okay, so, and it's 0 for m equals to n equals to 0. Okay, so it's pi for m equals to n but does not equal to 0, and it's 0 for m equals to n equals to 0. Okay, so in this case, once again, in this summation, the only term that will remain is the term where n is equal to m. Okay, because when n is not equal to m, okay, this integral is just 0, so all the terms in the summation will go to 0. Okay, so what we get here is the integral from negative pi to pi f of x sine of mx, okay, dx, and that is equal to b sub m, okay, times pi. And from here we can solve for b sub m, and that is equal to 1 over pi, the integral from negative pi to pi f of x sine of mx dx. Okay, once again we're looking for b sub n, but remember here n and m are equal, so we can just write this as b sub n, that is 1 over pi, integral from negative pi to pi f of x sine of nx dx. Okay, so that is our coefficient b sub n. Okay, so let me summarize now. All right, so we've calculated here our Fourier coefficients. Okay, this is a0, this is a sub n, and this is b sub n. All right, in the next video, what I will do is take a function and calculate the Fourier series associated with that function. So using our knowledge here. Okay, so thank you.